Hello, everyone. In this part of the lecture, this is the uh, actually the last part of the lecture, and we have discussed about finding the present value of future benefit of a life insurance product and how to find the present value of an annuity. Then the use of those two will be calculating the premium for a given life insurance product. So in this chapter, we will discuss how to use the benefit present value and the present value of annuities to calculate a premium for an given for an insurance. So we have to think about the age and the terms in terms of years or months, and then the way the benefit is being paid and the way the premium is being paid. So considering these things, we will calculate different premiums. And to begin, let's discuss about the nature of these insurance system, where we have a policy, which is a contract in between the policyholder and the insurer, which legally state what are the conditions that the risk has to fulfill in order to be um, paid or compensate. That means not all risks are insurable, and the premium is the payment made by the policyholder, and the benefit is the amount paid by the insurer upon the occurrence of the event. And if you can visualize this, says we have the insurance and we have insurer and the policyholder or the insured. The policyholder pays a premium and insurer pays a benefit if it is needed. So the benefit is not always being paid, but the premium has to be paid at the according to the agreement. So it can be one premium or it can be a series of premiums, but always the benefit is one payment. But sometimes, like a pension plan, both benefits and premiums are paid in annuities. So mostly for the premium part, the premium payment scheme, so we apply the annuity, but depending on the type of the insurance, there will be one benefit payment or a series of benefit payment. In that case, if there's one benefit payment, we use the present value calculation equations in the chapter 4. But if it is an annuity, we use the lecture 5 or chapter 5 equations. So single premium is a lump sum paid when the policy is issued. That means we can buy the insurance by paying one amount, like one lump sum amount. So then you don't have to pay anything. So your insurance will be valid for a period which is called the coverage periods. For an example, if you are going on a vacation, you can buy an insurance for your health. So you in upfront you will pay uh, an amount, and the company agrees to provide a coverage for, let's say, 3 months. So then you just have to pay one amount upfront and by the time of purchase, and you don't have to pay anything. And the benefit can occur in multiple occasions. If it is a health care coverage, then there's a irregular annuity that fits to those kind of things. So that's how we decode it. And the benefit can be defined in many ways, as I mentioned. A discrete it's like the benefit can be paid for the life insurance. Always the event is death, so the benefit can be paid at the moment of death, or benefit can be paid at the end of the period which the death occurs. Like if the period is annual, so then the benefit is always being paid at the December 31st. But if the coverage period is um, compounded monthly, so then the benefit can be paid at the end of each month for deaths occur during that month. So, and the other thing is we can have a fully continuous benefit payment, which means the benefit will be paid at the moment of death. And there can be another case which is semi-continuous. So for some periods, the benefit will be paid at the moment of death. For some periods, the benefit will be paid at the end of that period, if the death occurs within that period. Then, in a general policy, we have level benefits and level premiums. That means we assume that the benefits are equal no matter how that is being paid, or no matter at what time it's being paid. That means you can expect $1 if the death occurs within the first year, and you can expect $1 if the death occurs after the first year. Always the benefit is same. And the premiums, always we pay the same premium throughout the uh, premium paying period. That means in this month I pay $1, next month again $1, like that. At each time I pay the same amount of benefit. That's why it's being said that the level benefits and premium apply. But there are cases where the non-level benefits and premiums are being paid. So we discussed some of these examples under the benefit present value and the annuity. It says the increasing annuity. It's a non-level case. So in the first year we pay $1, the second year we pay $2, $3, likewise it increases. And for the death benefits as well, if the death occurs within the first year, you can get $1 as the benefit, and if the death occurs in the next year, it is $1.50, like that. The benefit scheme get increased by 50 cents at that. So we can define the present values for $1 and or $100, and then we can multiply it by a constant. The present value doesn't change, the calculation doesn't change. We just need to calculate or multiply the present value by that constant in order to have that uh, value, or the actual value, which is corresponding to the actual benefit. So if you are using $1 assumption at the level benefits, you can assume that the benefits are $1 and the premiums are also $1. Calculate the present values and then multiply it by the actual premium, so that uh, you get the actual premium payment present value. And if you multiply it by the actual benefits, you get the actual benefit present value. And to calculate this premium, we can have can identify three different methods, the common methods: the equivalence principle, the percentile principle, and the return on premium principle. So in this course, we will discuss about this equivalence principle to calculate the net premium. And it says we consider that the present value of the future benefit, is same as the present value of the future premium payment. So you don't have any discrepancy. So at the beginning, you have present values equal to both uh, benefits and the premium payment schemes. That means no one gets an advantage from the insurance um, at the time of purchase. But after that, the things changes, the present values changes, because um, suppose if you have purchased a whole life insurance and only pay premium for first 10 years, so then after the first 10 years, you don't have any premium payment. So the present value of the uh, premium payments will be zero after 10 years. But still, if you haven't claimed the benefit, so then your future benefit value will be a positive value. So that's how uh, it changes. But at the net premium, you always assume that at the beginning. That means at age X, you know that Tx is zero. So this is the beginning, which is the time point of purchase. So at that point, the present value of uh, premiums and the present value of the benefit. So premium is a series, benefit is only one instant. So the present value of the benefit and the present value of the series of payments will be same at this point. So that's how it works. And we call the premiums that are being calculated using the equivalence principle as net premiums, or sometimes you might find this is called benefit premiums. So net premium and the benefit premium stand for the same quantity. So, sorry, the motivation is the actual present value of premiums that means the present value come from this will be equal to the actual present value of benefit. That means the difference of these present values should be zero. So now we can try to visualize this concept. So when we have a discrete N-year endowment insurance, assume it is said that the fully discrete N-year endowment insurance. That means the benefits and the all on the one so in the endowment we have the death benefit and also the survival benefit at the end of the period. So there are two cases, the benefits. And for the premiums, it's fully discrete. That means we assume the premiums as an annual premium scheme during the coverage period. So for N-year case, that means starting from zero, it should go up to N and 1, 2, and we have N minus 1 and N here. And the premiums, unlike, so always we assume that the annuity or the premium payments are made at the beginning of the year. That means we have to use the annuity due in calculating this uh, premium. And the other thing we need to assume that the benefit is $1 and all the premiums are uh, equal to the level case. So then the premium of the $1 benefit, fully discrete any endowment insurance, is denoted by P for premium. It is capital P now. Previously, we used the simple P for probability, the survival probability, and this is the age by now, and this is the coverage period. So it's similar to that endowment present value. So if it is for an endowment present value, we use capital A in terms of capital P. So that's the difference. So we pay one premium in here and then another premium at the beginning of the first year. So this is just a notation and it says the year you buy the insurance and the coverage years you have. So this is same as the premium you paid in the next year and also the following years. So you pay these premiums up to the nth year, which means the beginning of nth year. So you stop by here. So those are the premiums. But the benefits are being, since it is fully discrete, the benefit can be paid at any year end. So it can be paid in here, it can be paid in here, here, or here. Starting from the first year end, it goes to the nth year end. But it is only $1. That means if you take the death benefit at this point, you don't you will not get this because the death has occurred during this first year and there's no person. So there doesn't exist a person after this point. So that's why the benefit is directly denoted by 1, but the premiums, the present value should be the present values of these p's should be equal to the present value of this 1. So we don't know when this uh, death occurs. So that means if you recall, we always say if the death occurs, this is the present value. And if you survive from this year and the death occurs in the next year, then this will be the present value. And likewise, we build it up to the n years and then get the summation. But in here, the condition is no death occurs, assumes always the policy holder has to be survive at this point to pay this premium. That means if they survive, this is the first payment. If they survive, we have another payment. If they survive, we have one more payment like that. It goes up to the beginning of the first year. Then we know that. So this is the endowment present value. We denote it by at age X goes for n years. So that is the benefit present value. And the premium present value means this is the $1 annuity due for n-year period. So that is the temporary life annuity for n years. So the ratio gives us the premium corresponding equivalence or the premium calculated through this equivalence principle. So this is the premium we get for this endowment insurance. So this is a notation. It says the premium of an fully discrete n-year endowment insurance purchased at the age of X. And to calculate that, we get the ratio of the benefit present value and the premium present value, which is the annuity due of n-year temporary life. And we know that from the YZ uh, relation, we can calculate. If we know capital A, we can calculate simple A. If we know simple A, we can calculate capital A. And also we need to know about the insurers interest rate to calculate delta or D. And the other special thing is the premium is calculated for $1 benefit. That means, suppose if you have the death benefit as 10,000, so then you have to multiply this by 10,000. Eventually, you will multiply this PXN by 10,000 to get the actual premium amount. So if this insurance going to pay $10,000 at the death, that means the present value of 10,000 benefit is divided by a series of premium, and we need to calculate the value of premium. For that, we will divide the present value of the benefit of 10,000 by the present value of series of premiums, which is carried out for the first n years. So that's the meaning of this one. So if you need to get so this is for $1 benefit. So if we get S as the benefit, then the premium is S times the $1 premium. So that's how we get it. quickly. And also, we know this relationship. So you can use this and calculate this anytime. And I saw in the previous example, we can calculate these things using uh, the standard life table if the interest rate is 5%. So that's how we can calculate the premium for a fully discrete N-year endowment insurance. And now, let's say we have M payment N-year term insurance. That means we have M amount of payments and the coverage period is N-year term. Still, it's discrete because it's M payment, and also we have $1 benefit because every time if it is not stated, we have to consider the benefit is $1. So in this case, we have N years of coverage, but the premium is being paid only for the first M years. That means we will pay a premium at this point, a premium at this point. So then the coverage goes for N years, but the premium is only paid for M years. So we have M for this notation, and its term, it's like a term life. So we have that 1 to denote. So I'll use a proper notation so that you can see it clearly. It's like this. It's the premium for a N-year term benefit. So this is the term life notation, but the premium is only being paid for M years. So this is the notation. So this is the premium. So this amount is being paid throughout this year up to this point. After that, there'll be the coverage period will be there, but no premium payment will be there. So this one can happen at any time during 0 and N. So that's how it works. So then to calculate the premium of a person who is at age X, which is has coverage for N years, and the premium is paying only paid for the first 10 years. So the benefit is a term life of N years, and the premium is an annuity due and a temporary life annuity due for M years. So that's how we get it. And suppose we have a whole life. For an example, if we have a fully discrete whole life, then the premium should be whole life, and the benefit present value is AX. The premium present value is simple AX. So that's how it works. And we can discuss about other term, which is M year payment, N year pure endowment insurance. So this is a term insurance. This is a pure endowment insurance. That means the benefit is only being paid at the end of that period. So we know when the benefit is being paid. But for the term life and the endowment, we didn't know when the death period will be paid. So in this case, we have the benefit in here, which is $1, and we will pay a premium starting from 0 to m years. We have P up to m minus 1 year. And then the notation is familiar. The premium of a person who is at age X, the coverage goes for n years, but only paid at the end of the year. So this is same as the PO endowment uh, present value, which is uh, denoted by the capital A. And the benefits are being only paid for m years, so then you put m as a prefix. And for this, we can say the benefit is equal to the present value of the PO endowment benefit. And this is a series of payments, so a temporary life annuity of m years. So you get this one. And like in the in a special note, we know the endowment insurance benefit present value is equal to the term life present value plus the PO endowment present value. So premium of an PO endowment scheme, but the premiums are only being paid for m years, and then we can replace it by a premium of a term life with m payments and the premium for an PO endowment with m payments. So this is similar to this notation. So now you will see that this is just kind of an application of the previous two chapters. So once you identify the benefit scheme and the premium scheme, just get the ratio. It will gives you the premium with respect to $1 benefit. So that's the important thing. If you know the real benefit, you have to multiply this piece by the real amount to get the real premium corresponding to that benefit. Now we can calculate some premiums for these schemes. So we are given a constant force of mortality for all ages. We are asked to calculate the premium of a fully discrete. So if the premium has a capital P notation with the usual benefit notations, it says a fully discrete premium. So this is a fully discrete term life starting from age X to age X plus N. And then to calculate the P, we need capital A and uh, simple A's. So first calculate this one. So this is a temporal life annuity due. And we know that if we have the temporal life case, we can remember starting from k is equal 0, we go the summation up to n minus 1. And the present value is b to the power k, xk. This is the $1 annuity due of temporary life. And we know that if we have a constant force of mortality, the survival probability is e to the minus the negative power mu times k. K goes from 0 to n minus 1. And this is a summation of this finite series. And summation of this kind of a finite series is 1 minus Vn E mu n and V E mu. So this is the uh, term we get for this finite sum. And because this is the common factor and it goes for n terms, so we have 1 minus to the power n and we divide by the n, n equal or the k equal 1 time. So for the benefit, we have only one case, which is the term life starting from x to n. And this goes for k plus 1. For the benefit, it's conditional. So it's not directly the survival probability. The death probability upon the condition of surviving for k years. So we will have modified version. So if we take this v out, we have e to the power k. And for this one, surviving for k years, and then the death occur within the next year. So 1 minus the survival probability for 1 year. So this is a common factor, which means it doesn't depend on k, so you can get it out. And this part is again the previous part, which is a xn, or the simple annuity due. It's v to the power k e mu k. So you have this in here. So the term life benefit is this, and it has a common factor, which is this. So the answer is the constant we took out from the summation. And for part B, we have a uniform distribution of death. And to calculate the same amount, again, we'll go with this first. And this one is given from here. We have that equation. And if we take this out, and for this one, this is the present value of the annuity, we can have it in terms of the present value of the benefit from the YZ relation. So we decoded it. And for EXN, we know it's VN, PXN. So VN for PXN, again, it's N omega X. And under the uniform distribution of death, we have YC relation again. So we can substitute these things now. So PXN is AXN divided by A double dot XN. So you can substitute these two and get a ratio. So that is the abstract part. And you will see, so under the constant force of mortality, we can see the present value of the benefit includes the present value of the premium payment. So that's why, so this is the present value of the premium payment. So the present value of the benefit is a constant times the present value of the premium. That is under the the constant force of modernity. But under the uniform distribution, we have a complex equation, and this is somewhat easier to calculate, but this is not. So now we can write down the net premiums for standard fully continuous insurance policies. So it has the same definition, but I'll discuss about few cases. The notation changed a bit. So since it is continuous, suppose a whole life, then the premium is continuous. So we have a bar there, and the benefit is also continuous. So this is a notation to say that the premium is continuous and the benefit is continuous. And we get something similar to this. The present value of a continuous benefit for whole life is this, and the continuous annuity is this. So it's quite straightforward. And for n year term life, again, a continuous premium for a continuous term life of n years. The benefit present value of n years term continuous, and the continuous temporary life annuity. Then we can discuss about two more cases. The PO endowment case, n year PO endowment. Again, a continuous premium. The PO endowment notation is this. And since the PO endowment is one payment, no matter what it is, discrete or continuous, we have only one case. We don't have any bar about that. So the present value of the PO endowment is this for n years. This is same as this. And the premiums are being paid continuously for n years, and that's why we have this notation. So we have the PO endowment, you can have the n year endowment insurance. So the premium is continuous. The endowment notation is this. So the present value of the benefit is this. The continuous premium payment present value is this. So that's how it works. And suppose we can modify these things. For an example, if we have M payment year, whole life, then we denote it by a continuous whole life, but M year payments. So in that case, the benefit is valid for the entire life. It is continuously paid at the moment of death, and the premium only continues from X to first M years. So that's how it works, and you can modify it for the other cases as well. So if you see M before the notation, it says the premium payments are limited and the coverage period is longer than the premium period. So let's go to this example and try to find the premiums here. So we have to assume that the mortality follows a standard ultimate life table. So if you could remember, we had the life table example in the previous video. So we can directly refer that. The deaths are uniformly distributed over the each year of age. And since it is standard life table, I is equal to 5%, the interest rate is 0.05. So we need to find the premium of a continuous, fully continuous scheme. The benefit is being paid for the first 20 years, and also the premium is being paid during the first 20 years of a person who is at age 60. So let's do it like this. In the table, we have 10-year and 20-year endowment present values. So we can get 60 to 20 years endowment present value directly from the table, which is equal to this. And also the PO endowment terms for 5 years, 10 years, and 20 years are given in the table. So this is also extracted from the table. As I discussed in that standard life table section, so we don't have the term life present value in the life table. What we need to do is use the relation in between the endowment and the PO endowment. So you will get this. You can use this one or difference between the deferred life and the whole life case. So we did it in the previous case, so that's why I used this equation. So you know that there are two ways to get this. So under the UDD, we know how to convert the discrete present values into the continuous case. So the continuous present value of benefit is I divided by delta times the discrete case. So in here, first let's find it for the term life. So then the term life. So this is the continuous term life benefit. And you can take it directly. So we know that delta is the log value of 1 plus I. So you can directly get it from the calculator. And this is from the previous calculation. So the final value is 0.1181. And to get the continuous endowment, so you have the continuous term life plus the PO endowment. So PO endowment is same for both continuous and discrete case. So you will get this. And since it is UDD, we get the annuity so this is continuous, so both signs should be continuous. And for V, or since it's continuous, we divide it by delta. So the resultant value is 12.0257. Since you have all these things, to calculate the continuous premium for the term life of continuous benefit and continuous premium, you will divide the continuous whole life benefit present value from the temporary life annuity, which is continuous now for 20 years. So you will get an answer in here. And for this one, it's continuous again, but now an endowment present value. So the continuous endowment present value benefit divided by the same annuity, temporary life annuity of a continuous payment. So you will get two answers in here. So you have calculated all the things in here, here, and in here. So using these three quantities, you can calculate these two numbers. So now we will see it's kind of easy uh, to digest if you know the correct form of the benefit present value and the premium present value, which is the annuity due or annuity continuous annuity and the continuous or the discrete benefit payment. Then you can move to the net premiums for standard semi-continuous insurance policies and monthly payment policies. So up to now, we considered the annual cases. So whether we consider two cases, either it is fully discrete or fully continuous. Now, in the semi-continuous case, the benefit can be continuous and the annuity can be discrete, which means you pay uh, the premium monthly or annually or quarterly, you will get a death benefit at the moment of death. So that's the case. So that means we have a continuous benefit and you get the actuarial present value of the continuous benefit and divide by the actuarial present value of the discrete premiums. So these premiums can be either annual or monthly. So this is the premium. So that's the concept. So if we go through this example, you will realize this concept. In general, we can say, um, suppose we have a continuous endowment. So we have in year continuous endowment with monthly payments for m years, where m is less than or equal to n. Then the premium is a continuous endowment for n years. And since this is discrete, compounded for m years or m terms per year and paid for m years. So we have two m's and let's say, yeah, to avoid this confusion, let's remove this m from years. Instead of that, let's take h. So h years. H is years, m is the terms per year. So then you have h in here. So in this example, we can digest it easily. Suppose that the mortality follows the standard ultimate life table and calculate the level annual net premium payable quarterly. So since it is quarterly, we know M is equal to 4. Installment for 5 payment year. So payment year is 5, so H is equal to 5. For 10-year endowment insurance, that means N is equal to 10. And 5,000 is the benefit amount. So if you could remember, in the first definition, S is the actual amount of benefit. So S is equal to 5,000 in here. And X is equal to 50. So if you see the wording like insurance of 5,000 on 50, where the 50 is in bracket, that means the age is given in this term. So the person who is at age 50, the benefit is 5,000 and paid for during the first n years. And if it is not stated otherwise, we consider the death benefit and the uh, endowment benefit is same. So the death benefit is paid at the end of the quarter of the death. So the benefit is paid at the end of the quarter of the death, and assume that I is equal to 5% and the uniform distribution of death assumption holds here. So now they says uh, the annual net premium payable quarterly, that means it is also discrete. This is also discrete. So in this case, the premium should be the benefit compounded for 4 terms, and this goes for 10 years, and this is the term life plus the PO endowment of 50 to 10 years divided by, so that is the benefit present value, and for discrete annuity 4-year periods from 50 to, now the payment years are only valid for 5, so 50 to 55 for 5 years. So this is the ratio we want. So we can find this from the table quickly. To find this, so this is empty compound. Since we have the UDD assumption under the uniform distribution of death, we can directly find this using this relation. The annual present value of the term life for 10 years multiplied by I and divided by I4, which is the compound risk for power terms. And for this annuity due compounded for 4 terms, starting from 50 to 55, we can get it by here because it is under UDD. So alpha 4 and beta 4 can be found from the table because it's I is equal to 5%. It's given in the standard life table document. And since this is a term life, so we have to multiply beta by 1 minus the PO endowment part. So this is also found in the table. So you can get this ratio if you could remember. So this is I4 divided by 4 with 4 equal 1 plus I. So from this, you can get this ratio. This is available in the table. This is available in the table. This is available in the table. This is also alpha is also there and beta is also there. So all these quantities are in the table. You can find it and substitute these things in here. So your answers should be 0.018812. And for this one, you should get 4.45016. Once you get these two, and substitute those two here, take this from the table again and find P, which is equal to, so this P is for $1. So you will get uh, this one as yeah, for this one we need to find this from the table. So if you get this from the table, it should be The final value should be 1617 divided by 4,45016. So this is for $1. Sorry. And then the actual benefit is 5,000 times P. And this is for the entire year. And since the premium is being paid during 4 equal intervals or quarters, you have to divide by 4. So this is the premium per quarter. So now you will see always P's stand for $1 annual premium. So you have to first multiply it by the actual premium to get the actual premium per the year. And if it is monthly paid, so then you have to pay it, or the annual premium should be divided by the number of intervals per year. It is 4 in here. So that's why we got 5,000 times P divided by 4 as the quarterly premium. So we realized two new things in this example. Now, up to this case, we always had a level payment. That means if the benefit is 5,000, the benefit is 5,000 for the entire period. If the premium is fixed, so it is same for every time you pay the premium. But in the special case, now the benefit is different and also the premium is different. We can say, suppose we have a 3-year special case, special term insurance. So the benefit is 100, the benefit is 200, and the benefit is 300. The death occurs within the first year, second year, or the third year. And the premium can be 50, 51, and 52. So that means you pay 3 different premiums and you get 3 different uh, benefits. So the, we can say from the net premiums policy or the principle, we get the actuarial present value of premiums equal to actuarial present value of the benefits. So that means the APV, actuarial present value of premiums, is equal to the actuarial present value of benefits. So for this one, it's pi. Then discount this. If you survive from X to 1 year and discount it back, you will pay pi 1. And if you survive for 2 years from X, you will pay 5.2. So this is the present value of these premiums. And for the benefits, you will have, so I'll have instead of 100 and 300, I'll have B1, B2. So then it's more general, B1, B2, and B3. So then we'll have the present values of the benefits, like if the death occurs within the first year, we will get it back, which is equal to B1. In the second year, survive the first year, dies in the next year, the amount of benefit is B2. For the third year, survive for the first 2 years, death occurs in the next year, the amount of benefit is B3. So now you will see you have a system, and always like the present value of these benefits and the future premiums are equal, but you have a system of equations to solve. So if this is continuous, you have integrals on both sides. If it is semi-continuous, one side is continuous and the other side is discrete. So that's how it works. But most of the time, the premiums will be level premiums because in the business, we don't want the customer to pay different kind of amounts depending on the time. So if the customer pays a constant amount throughout the coverage period, customers are also happy to be with the company. But the benefit can be changed. So most of the practical cases, these fives are equal. But you can design different insurance portfolios. So you don't have to um, like worry about the other um, different paying schemes. So finally, we can discuss about one more example and then we can see how these things work. So the next topic, which is the loss at issue random variable, I eliminated that topic from the syllabus and the percentile premium and the profit uh, because the last time I got a feedback from the class. So since these are within the limited period, we cover many different topics. So it was too hard for them to follow these next two chapters of the textbook. So we will stop from this premium calculation. And on the next video, I will cover kind of a revision from the beginning to the premium calculation so that you can recall all the equations we have discussed during the lecture for the exam uh, through that revision uh, video. So this will be our final um example for the topic. Though there are uh, like we have few more topics to come under the present value or the actual present values of the future uh, different kind of premiums and the loss at issue random variables. So these will these topics will not be discussed under this course. So let's focus on this example. But I will give you some of like some kind of notes for this section if you like further readings. Uh, and this section will not be covered during the final exam. So let's discuss this example. So the I is 4, that 4%. That means we cannot use the standard life table in here. Um, the first annual premium or the first annual payment is 1,000. The payments in the following years increase by 4% per year. So now the payments are also increased. There's no death benefit during the 3 deferral period. So that means during the first 3 years, we don't have any death benefit payment. That means this is kind of a deferred coverage. And as I say, it's special 3-year deferred whole life annuity due. That means after the first 3 years, we have a payment of 1,000 starting from 1,000 and it increases till the uh, death occurs, the occurrence of death. And there's no death benefit during the first 3 years, but the level premiums are payable at the beginning of the first 3 years. So that means we will pay 3 installments or premiums for this payment scheme. And then the company will start paying us starting from 1,000 and increases by 4% per year till the death occurs. So that's the nature of this payment. So if I visualize it, says we have the deferred period from 1 to 3. And from this point onward, we will have 1000 and 1.04 and 1000, 1.04 to the power 2. And it continues till the death. And the premiums are equal 3 payments made at the beginning of each year during the first 3 years. So this is the case. And also, since we have benefits and premiums at the same time, we always prefer to write benefits above the timeline and premiums below the timeline. So it keeps our word tidy and clean. So we can refer these diagrams and then write down these equations easily. So the first thing we need to do is write down this or draw this diagram, and then we can write down the present values and of the premiums and the benefits correspond accordingly. So that makes our effort easy. So now they have given the current future lifetime at X is 11.5 years. That means for a person who is at age X, the expected life, future life on average is equal to 11 years. And they have given the survival probabilities from X to 1 year, X to 2 years, and X to 3 years. Calculate the net annual premium, which is 5. So since it is net annual premiums, so we need to use that equivalence principle. So let's start with the actuarial present value of premium incomes. That means we have 3 payments or premium payments. We get it like this. The the present value of premiums is equal to premium amount is pi. So since we have an equal amount, so we can multiply the $1 amount, which is the annuity due of a temporary life of 3 years. But to get this, we need to, since there are only 3 terms and the probabilities are given, we can find it like this. 1 plus, if they survive the first year, then the second payment comes. And if they survive the next year, then the third payment comes. So it's like this. The probability is 0.99 and the V is 1 over 1.04. The probability for 2 years surviving 2 years is 0.98. The V square is this. So we will get 2858 times 5. So that is the present value of the premiums. And the actuarial present value of benefits equal to a deferred whole life. So that means starting from, so case 0 for this year, 1, 2, and from this point onwards, we have the payment series. So unlike in the previous insurance, where one benefit is being paid, in here we have one payment at the beginning of each year. So that's why we need an annuity for here. So this is deferred whole life annuity. So it continues to the infinity. And the amount is 1000 times 1.04 to the power, and it's k minus 3 because when k is 3, this power is 0. That's why we don't have any the factor in here. When k is 4, its power is 1. When k is 5, the power is 2, like that. So then we can take 1000 out also. And yeah, so I forgot. So this is the payment amount. So we have to discount it back by K. And the probability of surviving for K years is here. So now we can take 1000 back. And for this, I can make K minus 3 by taking 3 b to the power 3 out. So that means starting from K equal 3 to infinity, we have 1.04 to the power K minus 3, b to the power K minus 3, and the probabilities surviving from K to X to K years. So now, yeah, we can do this and we can think of, like, since we removed this one, so we have to simplify this. So now we don't have this. So I think it's easy to go the other way, like this. And now we have I is equal to 0.04. So that saves our steps of calculation because this is the inflation factor, the 4% in here. And this 4% is coming from the um, interest rate. So I can write down this part again as this. So then this will be cancelled out. So the final version will be 3 to infinity summation of these probabilities. So this is equal to, because we have these three in here, we can find this by 1 minus so it's not 1, we have the definition of this. First, let's take the definition from there. So definition for this one is starting from 1 goes to infinity, sum up all the survival probabilities. So this is the definition for this one. Therefore, this will give Ex minus the summation of Bx plus Bx2, and we don't need 3 here because 3 is included in this one, so we have only this. So we have all these 3 values with us. Eventually we get 9.8 for this one because these 3 quantities are given the question. So now the actuarial present value of the future benefits is equal to so when you multiply it by 1000 and divide by 1.04, or 4 to the power 3, you will get this one. So from the equivalence principle, we get 2858 pi is equal to 8072.087. Therefore, pi is equal to 8072.7 divided by 58, which is equal to 2824.4. So now you can see this was a special case where this is not a benefit payment for death. This is kind of like a pension plan or retirement plan. So you contribute the same amount annually for a given period, and after that period, you start getting payment from the um, company until the death occurs. So now in this section, so we discuss the possibilities of all 4 cases. The benefits for fully discrete benefits and fully discrete premiums for whole life and for term life as well. And in some cases, the coverage period is higher than the premium paid cases. So there we use monthly payment, monthly coverage case. So M payment year and N year term insurance, and for the pure endowment as well. And we calculated fully continuous. The benefit is be paying at the moment of death, and we consider that the premium is also paid continuously at the same time, but it's not practically implanted, but we can calculate these things and get a present value for annual value and decide the premium. And the other thing is all these premiums are decided considering $1 or 1 rupee benefit payment and the annuity payments. That means if you have the actual benefit amount and you have to multiply this amount by that actual amount to get the annual pay. If the payments are made or the premiums are paid in equal intervals during the year, so then you have to divide that number of intervals from the annual increment to get the premiums per that interval. So that is the special case we considered on the other. And also we have semi-continuous cases where the benefit can be continuous and the premiums can be discrete. The more practical case, but we can have the vice versa as well. And the other thing is the benefit and the premiums can be paid in monthly or quarterly intervals. So then first you have to think about the annual and then think about the compound monthly interest rates and then convert it accordingly. Most of the time, if we assume the UDD assumption or uniform distribution of death, we can use that alpha x and alpha m and beta m equation to calculate the discrete monthly compounded annuity due value, and also uh, we can calculate the monthly compounded benefit present value using I over im equation, converting the annual benefit present value into monthly benefit present values. But always we consider under this equivalence principle, the actuarial present value of the benefit is equal to the actual present value of the premiums. And in this special case, we can have different amount of benefits and different amounts of premiums throughout the year. So then we have to stick to the fundamentals and derive it from the beginning or scratch. Sorry. And the other thing is, if we don't have, so if we couldn't find any interest rate in the equation or in the question, we always assume that it is 5% and we can use the standard ultimate table. So in the standard ultimate table for 5% level of the interest, we have the number of survivors and the annuities for 10 years and 20 years and the benefits for 10 years and 20 years and also the PO endowments for 5-year, 10-year and 20-year periods. Also, you will find that you under the UDD assumption to convert the annual terms into monthly terms for alpha M and beta M's are also given. And also some of the equation for an Wolfram formula, it's given. Gomper's law is given in that formula sheet. So I'll share that formula sheet with these lecture notes today. And then, so in the final example we considered in here, we calculated the present values, but the benefits are now kind of a payment scheme. So this is much similar to a retirement payment scheme. So you contribute a similar amount throughout the payment period, and at the end of the payment period, the company will start to pay you, and that amount can be a constant value for the entire time, or it can be increasing time to time, like the example in here. So in both these cases, we have annuities for benefits and the premiums. So that's the uh, like the different varieties that we can discuss within this course. So in the next part, we will go through all the equations and topics that we have discussed up to this point to conclude the lecture. So this all for the lecture series, and I'll share the external or the extra notes for the Losat tissue random variable and the percentile premiums for your knowledge. But that part will not be covered for the exam. And this is the end of the lecture series. Thank you.